we're going to learn about activation functions here. So, what activation functions are? Imagine you have a computer brain called neural network, and it helps us figure out things like pictures, words, and sounds. But this brain needs something to help it understand things better. So that's where activation functions come in, right? So activation functions are like a special helper that make brain work better. They make the information the brain from its eyes, ears, or other senses and turn it into language the brain can understand. And think of it as like a robot that can only understand the numbers, and if you give it a number, then it will sit there and do nothing. But if you put a special code in front of the number like 0.5x plus 3, the robot will start to do the work. So it will use this code to make decisions or solve the problem. So activation functions are like these codes, and they take the information that brain gets and turn it into something useful. Without them, brain wouldn't be able to understand things correctly. So that's the basic thing behind that. And in the previous video, I was talking something about these things. So the activation functions are these things. So these are activation functions. This is the first of the activation function, and the things that I'm writing in the square things, those are layers, right? And the things that I'm going to write in parentheses or circle brackets, that will be different things. So just in case. So this is our basic neural network. In this one, we're just going to visualize some things. So we're going to think these activation functions as different functions as a g, alright? G of z1 and g of z2. So normally activation functions are like sigmoid function. That's what we used to use before. So it used to look like something like this, and it used to be a equals to 1 plus e minus z. And so the g function is non-linear function, which is not sigmoid function, alright? So whatever g is, it will not be sigmoid function. So g function will be working better than sigmoid function or hyperbolic function. So let's suppose tan h function for g right now. So this will be our tan h function. So this is 1 and this is minus 1, and the tan h function will be looking like something like e of z minus e of minus z divided by e of z plus e of minus z, alright? And it will be y will be between 0 and 1 in the cases. Normally this will be working really better than sigmoid function. And in only the binary classification, that's where we are going to use sigmoid function, and other than that we're going to use the tan h function. Activation functions can be really different for different layers. So this layer we were talking about, so these are the, like, this is the first layer, this is the second layer, and the first layer can be tan h function, or it can be ReLU function. We'll talk about that, ReLU, rectified linear unit function, in a bit. Or it can be a sigmoid function. So normally we tend to use sigmoid function in the last layer or the second last layer, and we're going tend to using the ReLU or tan h or any other function in the previous ones. And then hidden units will be looking like g of z1 equals tan h of z1. So if c is very large or small, then gradient or slope will become almost zero. So that will be the thing. So the rectified linear unit, the ReLU, which is the function where we are going to make any negative thing zero, and we are going to have any positive thing. So it will be looking like max of 0 and c. So normally whenever you're training your neural networks, the ReLU function is really better for your neural networks, because it makes your network learn much faster than sigmoid or any tan h function can do. And ReLU is like really popular thing which is going on nowadays. So rules for tan h will be, we have tan h, then we have ReLU, and then we have sigmoid, right? So rules for tan h will be 0 or 1. That's where we use sigmoid, right? So, and then all other, if we have 0 or 1, all other we are going to use ReLU by default, and sometimes we are going to use tan h. And there is something called leaky ReLU as well, which will be looking something like this. So that will be our leaky ReLU. This is our sigmoid, this is our ReLU, this is 0, right? And this is our tan h. So derivative of c will be different than 0 in the leaky ReLU. So it will be having something like max of 0.01 and c. So that 0.01 will be giving this line like a little bit off from 0. So normally we are going to never use sigmoid function, only in binary classification. That's where we are going to use this thing. Then tan h is better than sigmoid, so the formula for that was this. It is better, so we use it sometimes but not all times, and this is the best thing, which if you don't get what activation functions you want to use, then just blindly go for ReLU. And leaky ReLU performs better than the normal ReLU, but it is trickier to perform. So I want you guys to go through each and every activation function, go and implement all of these on your personal neural networks, and it will give you much more better understanding about how these all are different. So normally whenever you guys are going to be working, normally the industry standard is using ReLU, but if you guys have some different use cases, it might be useful for you guys to use only sigmoid function if you're classifying things binary, like using binary classification, or 10H might be the thing for you if you're doing some different things, or leaky ReLU might be the thing, because even if it's being trickier, it is better than the normal ReLU. So that's what are the different choices. So that's all for this video, and keep hustling. I'll see you in the next one.